Alright, we are recording. Yeah, lots of delays with the snow. It's actually, it's looking pretty clear out there now. Although the melting snow turned into a water leak in the ceiling on yesterday. So that's fun. Car stuck in the parking lot. Yeah, hopefully it thaws out quickly. It's pretty melted here. 1.5 feet of snow. Wow, that's awesome. Yeah, that's impressive. All right. Oh, leaking the network switch. Yeah, that's not good. Yeah, this did no damage. I discovered it in the middle of the night, and other than a wet floor, it was fine. It missed my 50-pound bag of flour that I got from COVID stockpiling, and my big bag of rice, and all of that came out totally clear. So lucked out. All right, a zillion things to go through today. So let me start by talking about the ODP that's posted today, and then I want to talk about the Service Learning Project, and then review PA3, talk about the midterm, and then start talking about PA4. All of this is on Canvas, and I mentioned some of it in announcements yesterday and today. So let's just go ahead and jump into this and see how far we get. So first of all, ODP 211 is posted, and you can read about it under /temp. So this week's ODPs are about binary trees, and we're going to start building trees and then doing some manipulation of them over the next few days. So today's ODP, you're basically building a small tree containing 3 nodes. So the structure of a node has to be exactly like this. Remember, the order of these matters. If I declare data between left and right, my code won't assess correctly. So for these ODPs, data comes first, then left, then right. And this comprises a T node. Your data is an int. Your left and right children are pointers to T nodes. And you're making a function named small. And small accepts 3 integers and returns a pointer to a T node. And that pointer is the root of a tree that you're building. And you're building a tree containing these 3 integer values, where root's obviously the root value, left is the left child, and so on. So what do? Your small function should do the following. Allocate space for a root. Okay, that's a call to malloc, size of struct T node. Allocate space for a left child, allocate space for a right child. So 3 mallocs. And then set the data field of each of those 2, respectively, root, left, and right. And then set the left and right fields of each of those as follows. The root's left child should be whatever your left node is. Root's right child should be whatever you call your right node. And then left and right, those nodes, the left and right children, should be null. So piece all of that together, return the address of the root as the function value, and you're good to go. That's the whole 211. And this one, I would say, if you want to write it and just go ahead and assess it and see if it works, that's totally legit. If you assess it and it doesn't work, then you want to write yourself a main program, right? In your main test bed, declare a struct T node. Make a pointer, call it, my root or something like that. That's a pointer to a struct T node. And then write 1 line of code, my root equals small parentheses, and pass 3 interesting integers. Don't just do zeros, but pass, interesting integers you're not likely to just run into randomly. And then run this in GDB. And after you come back from your small function, look at the thing you assigned it to and start making yourself a memory map. Okay, this is a really good, entry point into using GDB to look at dynamic memory. and play around with it from there. All right, any questions on how to do 211? All right, on to the service learning project. So let me pull up my Canvas shell. So you've been working on your service learning project. You made a proposal, you uploaded that, we went back and forth on it in some cases. You have 2 final deliverables for the SLP this quarter. The first is your final upload, the second is the presentation. They're worth 50 points each, total of 125 points for the SLP. So let's look at the upload criteria. This is due on March 1st, okay? And there's no wiggle room on this. So March 1st by midnight. So this is your one-page synopsis of what you've done this quarter. And you can download a template. And it's funny that when you click on the name, it takes you to a download. And when you click on the download, it gives you the option to preview. Oh no. Developing your SLP in Windows, really? I think Unity's fair. Oh, but you're doing VR, right? I know some people who are doing Unreal and are having pretty good success using that for virtual reality. But yeah, it is a machine hog for sure. Yeah, but developing under Windows, really, is that what you've been driven to? Or roll your own, you know. Just write your own drivers and come up with your own VR engine. That could be righteous. All right, so here's the one loader that you want to upload for your final upload. So fill this in, okay? Don't leave the project title as project title or the date as comma date. Put in the name of your project, right? And try to come up with some sort of snappy title if you like, right? Put down the date that you're filling this in. Hopefully this date does not say, you know, September 2021. Hopefully you're doing this like, you know, close to the time that you're uploading this. If you have a team that you're working with, right, come up with a team name, put that here. But regardless, make sure the name of everybody who's working on this project is listed here. And this has to be a full name, okay? First name, last name. If you want to put nicknames in parentheses, you can do that. But don't use initials, you know, or abbreviations or things like that. Make sure this is your full name. Team name, if you want to name your team, you know, go for it. If not, don't worry about it. But a lot of people, when they're working with a group of people, they'll come up with some, you know, snappy name for the team. You know, like in CSE222, when you do sumo bots and you have your team competitions. All right, problem definition. This is kind of you know, the crux of your project, and in particular, the problem statement. So what is it that you're doing, right? This is your elevator pitch. This is your 20 seconds in an elevator with Elon Musk, captive audience. How do you describe what it is you want to do in a way that hopefully, like, you know, conveys enough of the idea to convince this person to take out their checkbook and write you a check for $1 million to do your project, right? So what's your problem statement? Try to make this, you know, concise but complete. It's a really hard intersection to achieve. You can talk about the scope of the project. So what's in scope, what's out of scope, schedule. which at this point, you know, you're going to have basically the break and then one more quarter to work on this. And then resources that are available for it. Let's see, is it just my audio that's choppy? Is my internet cutting out? I'm losing it as well. I have the same on my end, same here. Maybe it's me. Yeah. Well, so I hacked down my audio, my video settings to bare minimum. But, you know, could be Comcast stuff going on. So the recording should be fine. So let's try to, let's hope it gets better live, but hopefully the recording is not choppy. But yeah, I don't know what to do. Maybe it's my excuse to get fiber. I don't know. I rebooted yesterday. Best excuse for fiber. Alright, I will, well, I'll slow down a little bit. I don't know if that'll help. So, problem definition, right? Put that up here. That's basically the gist of what it is you're trying to do. Let me see what my CPU hogs are right now. Very little CPU hog going on. Zoom. Alright, I will... Oh my. Alright, I'm just going to wing it. I'll try to shut down Chrome in a bit. Alright, so problem definition up here. Competitive analysis. So, you know, compare your project to what's out there. What are the pros and cons relative to what's out there? We're not grading the SLP based on, you know, is this something that has never been done before? Is this better than you know, what everybody else has come up with? Is your game going to be better than, you know, what comes out of Valve or something like that? But do some analysis, right? Think about this compared to other things in the same competitive area, and think about some pros and cons of your approach. Potential applications, right? So where do you see this being used? Future improvement ideas, stuff for down the road, including next quarter. And then the right side of this, solution specification. So this is where you basically say, what have you got so far for how you're going to, you know, solve your problem. So this can be, you know, a very high level outline. If you're at the beginning stages, it can be, you know, block diagrams. It can be, you know, code snippets, circuit diagrams. Whatever you think helps explain your solution spec. But you've only got half a page for this, right? This whole thing has to fit on one page, right? So it sits in here. So you got to do some thinking, and you got to do some prioritization of how you're going to present and what you're going to present. So think about that, and then, you know, solution specification over here. So this you put together and you upload by March 1st, midnight. All right, so that's your first deliverable. The second deliverable is the presentation itself. So the presentation takes place on March 8th. That's the following Monday. Okay, and it's during the regular class time. So for us, it'll be 11 o'clock to 11:50. And Izad is working the tech side to set up basically kind of a virtual collaborative space. So there'll be a series of breakout rooms. There'll be approximately 4 people per room, and you'll present your project round robin fashion. So each person will do like you know, a 5 to 10 minute presentation on their project. And other people, visitors and guests, will basically wander from room to room, and we're trying to set this up so that they can, you know, come and go as they choose. They don't need to be invited to a room or assigned to a room, but they'll see a list of topics and names of people presenting on their projects, what the projects are and what room they're in, and they can say, you know, oh, I'd like to learn about, you know, the hamster powered lawnmower. So they'll pop into the room, and you know, someone will be talking about their project. Um, and do a 5 to 10 minute presentation, so just a little bit of a pitch on your project, and then, you know, questions and answers as they come up, and so on and so forth. Very informal, very low key. You're not graded on, you know, the quality of your presentation or what you're wearing or anything like that, right? But you do have to show up and you have to participate. Okay. If you don't show up, it's a 0 for this part of the SLP. But you know, it's during regular class time, so the expectation is everybody will be there. And you know, we have not done this online before. Normally, this is done in the digital lounge in the STEM building, and it's usually packed with people, and you know, the dean comes by and all this kind of stuff. We don't know how it's going to work online, so we'll see. But you know, it's a potential opportunity to, you know, pitch your idea, to get more practice, you know, talking about your project, to maybe get some new ideas from other people related to your project, but also a chance, you know, to maybe get some interest from someone. Sometimes people from industry come to these things, and you know, maybe somebody's interested in talking to you about this, or maybe, you know, you get a lead for something to do after graduation, or an internship or something like that, or maybe some funding, you know. So have fun with it. Don't get stressed over it, right? But do some planning for it. Think about what you're going to say, and you know, 5 minutes. You could talk about anything for 5 minutes, right? I mean, you could talk about the remote control on a TV set for 5 minutes. So spend a little bit of time thinking about how you want to present your project. And people are working on really cool projects in here, right? And I don't care if, you know, you've got the whole thing finished and working perfectly, or if, you know, you've gone back to the drawing board 2 days before the presentation and you have no progress, right? You've got, you know, 10 weeks worth of stuff at least that you've been doing towards this project, and that's all fair game to talk about, right? If you're switching game engines, you can talk about your experience with that. So those two deliverables are posted on Canvas now. And again, final upload is on the 1st, presentation is on the 8th. Any questions about those? All right, so I'm going to close this out, and I'm going to try to close out all of my memory sucking Chrome sessions. Not that I'm harshing on Chrome, it's just a reality. It's kind of what it does. Unfortunately, Zoom shows up when I look for Chrome jobs. That's a little weird. And I have like 3 Zoom sessions running. Alright, we'll see how it goes. Let's talk about PA3. So PA3, there's not too much I need to say because, you know, not a lot of surprises there. You knew how it was going to be graded. You knew what it was supposed to do. And by and large, PA3 looked great, right? Lots of hundreds, well, actually 120s, right? So lots of people turned things in by the deadline. In fact, almost everybody turned it in by the original deadline. So maybe I didn't need to offer the bonus points, or maybe that motivated people to get it done early. I don't know. But either way, most people took advantage of that and had it turned in by Friday morning. Almost no issues with downloading repos. A number of issues with what the file was named, but that's okay. I wasn't worried about that. And so let me pull up specific things I found. Extra points are nice, definitely. Let's see, homework's PA3. Alright, so yeah, most people submitted early. No makefile issues for the most part. Push and pop worked fine. Main issue that I saw operationally was occasionally seg faults, and usually seg faults when you try to pop from an empty stack or more often remove from an empty queue. And it's usually just mismanaging the list. So you know, not noticing that there's nothing after the sentinel and trying to do something with what the sentinel points to. That's probably the most common scenario. So take a look back at that, and if you can't figure out where the seg fault come from, come by office hours. Let's work on it. State management, I saw no issues with that. So everybody nicely managed being in stack mode or queue mode and responding to commands in the appropriate way. That's a really, really cool thing to be able to do, right? That's going to come up again and again in coding. And being able to, you know, change your response to a situation based on your state, that's a key ability. So that's really good. Printing stacks and queues, so that looked pretty good. I tried to you know, make sure everybody labeled top of stack, head, and tail, but as some people pointed out, that was not explicitly in the PDF, and so I gave back the 5 points deduction that I made for each of those if I deducted for that. Those would have been a 10-point deduction under issue with printing stack or queue, and I thought that would be kind of harsh, so I only took off 5 points. But I gave those back, and we will stick to the letter of the law on future assignments, so that there's not a question of, you know, was this described in class as a requirement or a suggestion or something. So no major issues with printing. The print formats looked good. Everything was separated by spaces, things like that. Main program looked really good. Picked up basic syntax errors fine. Parsed everything else correctly. That's good. Valgrind, almost no issues. I don't think I saw any memory leaks. I saw a few warnings from Valgrind, mostly dealing with empty structures. Definitely make sure once your code is done and you think it's all working correctly that you Valgrind it, and really exercise it under Valgrind. See if you can force Valgrind to complain about something, right? And if your code is super squeaky clean, that's just going to be fantastic. Compiler warnings, only had a few of those, so that was fine. Function comment blocks. So people are commenting their functions. We're going to raise the bar on that in PA4. I'm going to give you a specific format I want for those comment blocks, because even though, you know, a description of all the inputs and outputs are in your comments, I'm seeing a lot of this where it's in, you know, a paragraph of text. And the goal is, you know, I want to use this function. What's the third argument supposed to be? Well, you don't want to read through a paragraph of text. You want to be able to look at the function block and see a comment that says, you know, here's the arguments, first, second, third. Oh yeah, the third one is this integer that means this thing, you know. So I'm going to give you a specific format for that for PA4. Comment block in the start of main, I think only one person forgot their name, so that's good. Commenting throughout the code is looking really good, keep that up. Consistent indenting is looking good, keep that up. Overall, I was super thrilled with PA3. There were a lot of hundreds or 120s. And very little as far as, you know, oh boy, this person really does not understand what a stack or a queue is, right? Didn't really see that. So it's implementation details and so on. So that's all really good stuff. If you have concerns or questions regarding the comments on it, definitely come by office hours and ask. All right, so let's look at the midterm. And let me start clearing out my windows here to minimize space. So this was midterm B. All right, so the midterms were good. There was a potential for being nickel and dimed a little bit with some of the short answer questions, but those don't really worry me about, like, you know, where are you with respect to data structures and the computer science sequence and so on and so forth. But as far as the underlying concepts, people seem to be in good shape with that. So I was happy with the performance on the midterm overall. So let's look at the specifics. So question 1 was the bunny structure. So part A, declare a variable named bun1 which points to a struct bunny. So not a whole lot of options here. Struct is a keyword. Bunny is the name of the structure, and if you want a pointer to it, it's star bun1. You can put the star right next to bunny, you can put it next to the variable, you can put it in the middle with space on either side. But this declares a variable of type struct bunny pointer. Okay, it does not initialize bun1. Bun1 is not pointing to anything in particular. And right now, if I tried to use bun1, I would probably segfault. So usually the next thing we want to do is we want to allocate space, right? We want to have bun1 point somewhere. If we had a bunny structure somewhere we wanted to use, we could just set bun1 equal to that pointer. But here we're going to allocate space for this variable bun1. So that's pretty unambiguous in a number of ways to do this. Bun1 equals malloc. And then you need to tell it how many bytes you need. Well, the only way to do that that's legit is size of struct bunny. So that allocates space. And then write some data to initialize age, year, and time to 78. So that's just, you know, bun1 arrow age equals 78, bun1 arrow year, and so on. And you use the arrow because it's a thing pointed to by bun1 that we want to pull these fields off of. All right, write a declaration for an array of unknown length of struct bunnies named all bunnies. And there's really only one way to do this. Struct bunny all bunnies. Okay, that is an array of struct bunnies. It's not an array with any particular size, and in fact we haven't actually you know, set aside storage for that array, right? But this is declaring an array of struct bunnies, right? So we're declaring this variable. When I say all bunnies, it's an array of this structure. And if you try to do this with, you know, a bracket, you'll get a compile error. That's not valid syntax for declaring an array. We use bracket sometimes when we pass an array to a function. You'll see that in the argument list, but you can't use it for a declaration. And you'll pretty much never see me use square brackets. I like to stick with the pointers because these things are pointers. And by and large, right, that's what we're dealing with. We're dealing with pointers to memory locations. And brackets are nice and familiar. And if you actually have an array that's been declared, you can index it using brackets. But for declaring things, right, use a star. Now some people did star, and that is declaring all bunnies to be an array of pointers, right? That's different from an array of structures. It's an array of pointers to structures. So star doesn't get you there, although that's legal syntax. Bracket isn't legal syntax. And think about this sum, right? So play around with this. Make an array X of type char star. Make an array Y of type char star. and try to use those. Write some mallocs, write some loops to try to store some information in there, and then go into GDB and look at what you've got. Right? This is kind of a finishing school thing, right? If you can figure this difference out, you're probably done trying to figure out pointers, right? You've probably got it. So this is worth spending some time inside GDB. They do hurt. They're pointy, right? Double pointers. We rarely see triple pointer. At least I rarely see triple pointers. I think that would be more in scientific computing. So car star star y is a pointer to a pointer. But remember, if we shift our mentality and we think of this as a string, then this is a pointer to a string. And if we think of a pointer to something as an array of something, then this is an array of strings. So you got three levels here. You've got an array of strings. That's nice and comfortable basic programming, right? We've got a pointer to a string, which is how we think of arrays, or we've got a pointer to a character, which is what's really going on. So they're weird, right? That's the nature of C and arrays. Pointer to a pointer is used when you want, for example, an array of strings. Classic example of an array of strings, the list of arguments to a main program, which is why you declare your second argument argv to be a car star star. And when we say, you know, car star star argv, argv is an array of strings, so argv bracket 0 is your first string, that's the name of your program. Argv bracket 1 is your second string, that's your first command line argument, and so on. And each of these is a string, a car star, so we can feed it to string length and string compare and string copy and things like that. Or we can pull off individual characters by saying, you know, what's the first letter of your first argument? Argv bracket 1 bracket 0. So yeah, it's all connected. Pointer to a string. Now we're doing campfire songs. Maybe array pointer to a string array. I don't know. String I don't think works actually. All right. And then write a statement to allocate space for the all bunnies array. So that's another malloc call, right? So all bunnies equals malloc. Well, how much space do we need for one of these structures? It's a struct bunny. So we need size of struct bunny. And then multiply by 17 because we want 17 of them. Now, if you wrote a loop where you went through 17 times and malloc space for a bunny for each one, that's what you would do if you had a star star all bunnies. You would go through and you would set each of these things in the array to have enough space to store a pointer to a struct bunny, and then you'd have to do an additional malloc to actually allocate space for that struct bunny. But since we didn't have a pointer to a pointer, so if you just had a bunny, a single malloc statement where we get a chunk of 17 blocks of memory, where each one's big enough to hold a struct bunny, that's how we can allocate space for this array. All right. Linked list questions. So 3 linked lists. So the first one you just kind of have to work through, but you can label these things. This is list. This node is the thing pointed to by list next. This is list next next. This is list next next next. So let me bring up my list of issues. So So what do we get when we print list next data? So this is list next is this node. Its data field is equal to 20. So we'll print a 20 first, and then list next data. Well, this is list next, and list next data would be 23. So this would print a 20 followed by a 23. And most people got that. Okay, now we start manipulating the list, and this is where it gets potentially confusing. One easy way to deal with this is to use temporary variables. So make yourself some variables. Struct node first, struct node second, struct node third, right? Make them all pointers to struct nodes. And now do the following. First equals list arrow next. Bingo, this node is called first. Second equals first arrow next. Bingo, second refers to this node. Third equals second arrow next. Third refers to this node. And now you can laugh at these questions, right? So write some C code to delete the middle node. Well, how do you do that? First arrow next equals third, free second. Right? It's as close to trivial as you can get with anything involving dynamic memory. Because I have variables that refer to each of these, and I know to delete a node I should change this thing to point to the thing after it. Well, this is first arrow next equals third. Be sure to free the node's memory too. Well, this node is called second, so just free second. If you don't use temporaries, you have to get that same effect, right? So it's something like temp equals list arrow next, arrow next, arrow next, and then list arrow next equals, you know, temp arrow next, and then free temp, and so on. Temp would be list arrow next, arrow next. But if you don't like thinking in those terms, right, make yourself some temporary variables. And you're typing in this exam, right, so it shouldn't take you a whole lot of time to declare 3 variables, right? A couple of quick copy and pastes in VI and change the variable name. All right, write some C code to create a new node with a data value of 123. New equals malloc size of struct node, same as we've been doing. And then new arrow data equals 123. That sets the data value. Insert that node immediately after the 16. Okay, so depending on whether or not you did this after deleting that 20 node, you might have had one of 2 different answers, and I tried to give credit for both of those. But you know, to add a new node immediately before the 16, take the node prior to that, point to your new node, have your new node point to the 16. If you had your first, second, third variables from part B, right? This is just, you know, first arrow next equals new arrow next equals third, and you're done. All right, and then linked list processing. So linked list of nodes, which are integers. Write a function named product, which multiplies all the negative fields and returns that product. So a lot of ways you can do this. There's one way you can almost always come back to. So if you're starting with a sentinel node, make yourself a temporary. If you have a sentinel node, start off with the thing that points to. This will never segfault, right? If we have a sentinel node, that sentinel will never be null. So sentinel next is always something. Now sentinel next might return null, but that's just going to set temp equal to null. That's not a problem. And then here's the almost always safe way to traverse a linked list. Well, temp is not equal to null. Do whatever you want with temp arrow data, and you're done. Okay, there's a few issues that always are potential problems with linked lists. The first is accidentally using the sentinel, right? This will skip over the sentinel. You're not going to mistakenly use the sentinel's data value. Okay. The second is, you know, accidentally skipping the first node. So if I start using temp arrow next in here, right, I'm going to skip the first node. The third is not counting the last node. And this is guaranteed, you know, if temp is the last node, it's not null. So I'll use its data value, and then, you know, at the end of all this, I'll move down my list. I'll set temp equal to temp next. And that's going to set temp to null. And that'll kick me out of my while loop. The fourth problem is going too far beyond the end of your list and getting a seg fault. So there's a sweet spot in between all of those, right? This is almost always going to rest in that sweet spot. But however you do this, if you always try to do this by starting with Sentinel and you say, you know, if temp next is not equal to null, temp equals temp next, that'll work too, right? As long as it makes sense to you. But if you're trying to figure this out during an exam, you've got all these different pitfalls you can run into. So go back if that's the case and think about how you coded this and see if it makes sense. And if it doesn't, figure out how to make it sensical, right? And if you can't make sense out of it, try a different approach, right? Maybe start with a Sentinel, start with Sentinel next, maybe check temp next, maybe check temp, maybe do this in the beginning, maybe do it in the end, maybe do temp here, maybe do temp next here. There's a lot of variations, right? But take the guesswork out of it, right? Figure out a way to do this that absolutely makes sense to you and works. And then you're golden. All right, short answers. So abstract definition of a stack. What do we do with stacks? We push, we pop, we check to see if they're empty, we check to see if they're full, we initialize them, we peek to see what's at the top of the stack. That's pretty much it, right? And whether this stack is implemented with a linked list or an array or a bunch of monkeys holding bananas, when we want to pop something, we say pop. When we want to push something, we say push. This line here makes no sense if our stack is implemented using a linked list. There's no array involved, so there's no array length. There's no variable called SP. If this is a bunch of monkeys with cell phones and bananas, this statement makes no sense. These other statements are still fine. Abstract stack, abstract stack. So C is the outlying statement here. All right, potential seg fault. This is the classic seg fault situation. I've declared a pointer to an integer and I immediately use it before I've given it a value. That's going to seg fault, almost guaranteed. This up here, even though x doesn't have a value, it has a location in memory because I declared integer x, so ampersand x will be a location in memory. Down here I'm just adding 3 integers, that's always safe. And down here I'm setting y equal to the address of x, and x is an integer, so y points to a valid location in memory, and now I print the thing that y points to. That's just going to print the value of x. So these are all pretty safe. B is the one that's almost guaranteed to seg fault. 3, I was visualizing malloc 125 times size of double. Some people just did you know, double x bracket 125. That's okay, I gave you credit for that. Utility to detect memory leaks, that's valgrind. Most people knew that. Compiling a main program named main.c, so that's basically using the G switch on GCC. So GCC-G main.c would totally work. It names the output file a.out though, so you might want to name an output file with a -o switch. But -o has to be followed by the name of the file you want to create. So if you put your -g in here, it's not going to work. You might get a -g executable file, but it probably won't succeed in compiling main. Data structure known as a LIFO, that is a stack, last in, first out. Collision handling strategy where we rehash, that's called probing. So 2 strategies we talked about: chaining, where you use a linked list in each entry in your hash, and things that hash to the same spot go into the same list. Or probing, where when you hash and you find a collision, you rehash with a different function, typically a different probe value passed to the function, and you get a new index, and you keep doing that until you find a space to store it. So that's probing. True statements about hashes: they improve efficiency for storing and deleting key data pairs. Okay. by hopefully, you know, getting order one behavior, they probably take more space than parallel arrays, and there's nothing about what types of keys they can handle. Question 5. So question 5 was just GCC-G and then the rest of how you would compile your program. So GCC-G main or GCC-G-O main main.c. Either way is fine. But you can't do this. Right? Because that's going to try to make your output file a file called -g, and then it's going to try to compile two things, main and main.c. And main is probably executable code or it doesn't exist, so it's not going to compile. GCC, not GDB. All right, question 9, appropriate data structure for customers in a checkout line, that would be a queue. And then primary purpose of the hash function would be to choose an index in which to store a key, so C. Question 8, true about hashes, A and C, they improve the efficiency of storing and deleting key data pairs compared to parallel arrays. That's the whole purpose of a hash, is to get that order 1 behavior for storing and retrieving and deleting data, instead of just going through a set of arrays and doing either order n or order log n. All right, so PA4 is posted. Take a look at that. We will spend tomorrow talking about it in detail. But you can take a look at the assignment prompt, all 8 pages of it. You can look at sample code and start messing with that, and we'll start going through the details of it in class on Wednesday. All right, come by office hours if you got questions. Otherwise, I will see you tomorrow in class. Thanks.